This screencast is about finding quantum numbers for elements, and we're going to break the whole process down into two parts. So this is part one of two, and we will be looking at how you find the first two quantum numbers. Let's start by talking about what is a quantum number. A quantum number is a description for an electron that is in an atom. And the specific electron that it's talking about is the outermost electron. It's the one that is the new one added to each element. For instance, if you were carbon, you would have 6 protons and you would have 6 electrons. So it's addressing that 6th electron, the new one that was just added. If you go on to nitrogen, where you add another proton, you also add another electron. So the quantum number explains the location and the characteristics of that 7th, in that case, electron. It is a 4-digit number set, and each element has its own unique set of quantum numbers, and you can identify what element it is based on the quantum number set that you're given. The quantum numbers, as we're learning them, we're going to relate it to the periodic table. You'll be able to look at a periodic table, any periodic table you have, and through a series of 4 different little explanations, you will be able to come up with the quantum number for the 4 numbers for any element. And in reverse as well, I can give you the numbers and you'll be able to figure out what element it is. This idea was developed by Schrödinger, and an example of hydrogen's quantum numbers would look like 1, 0, 0, negative 1/2. All right, so finding the first quantum number. The first quantum number is called the principal quantum number, and we will use the symbol n when we're abbreviating for it. It's a lowercase n, it's going to be the principal quantum number. This one is going to describe the energy level of the electron. We know that Bohr models show the nucleus in the center and then a series of rings, which are the orbits, progressing outward. And each ring, each orbit has an energy level. So you start at 1 and you go 2, 3, 4, 5, 6, and 7. They're going to be whole numbers, and it can be, like I said, 1 through 7. And for the most part, we're going to reference on the periodic table. We're going to look at the row that the element is in order to determine the first quantum number. Now, there are 2 exceptions. The transition metals in the center of the periodic table, you're going to take row minus 1. And then the lanthanides and actinides, you're going to subtract 2 to find its first quantum number. Remember, the lanthanides and actinides fit in there in the 6th and 7th row. So whenever you are subtracting your 2, you need to make sure that you have the correct row number to begin with. All right, so to do this with the periodic table, it helps and it makes it much easier if you have a study guide in order to understand the 4 quantum numbers. And so I'm going to give you a blank periodic table in class, and we're going to make a study guide that will be helpful. You will not be able to use this on the test, but you can use it to learn and to practice from, and it'll make the whole process a lot easier. But we have to edit our periodic table first. The first thing we're going to do is we're going to cross off helium over here, and we're going to relocate it over here. So when you have your periodic table, it probably has hydrogen there. You're going to go ahead and add a box just beside the hydrogen's location. And if you want to even stick helium in there, you certainly may. It'll help you. So helium is moving over beside hydrogen. The second thing that we're going to do is we're going to place our lanthanides and actinides. So I'm going to use a star here, and I'm going to use a smiley face. You can use any 2 symbols you want. The star will be relocated up here in what is the 6th row. It is over. You have 3 boxes. If you count over 1, 2, 3, the star goes there, and the smiley face would go in the 7th row. So what you're saying there is that the lanthanides and actinides actually fit on that line between the 2nd and 3rd element in the 6th and 7th row. The last thing I ask you to do is you're going to number. You're going to number the rows, and it'll be helpful. Let's go ahead and put in some 5, 4, 3, 2. So we have our row numbers marked as well, and it is actually easier on you if you have them labeled the whole way down both sides. So those are the edits that you need to make to your study guide when you get it. All right, so let's put our first layer of information on our study guide. We're going to do the information for our first quantum number, which is the principal quantum number. And if you remember, this is an abbreviation of N, and we're going to remember this by finding the energy level. And that is known as the rho. Okay, so we're going to look at the energy level, which is the rho. So how we're going to do this, we're going to label this on the periodic table. Above this the first two columns on the left of the periodic table, we are going to use the label here that is going to be row number, because when we're finding these elements, we're going to just use the row number of the element that it is in. Then the last 6, you're also going to do the row number, so row number here, okay, and it goes this whole segment there. When you're asked to find an element's quantum number and it is in this first section here, you just look at what row number it's in. Same deal on the right in this section over here. If your element is here, it would have a first quantum number of 5. All right, and then we need to label the center section. We're going to go row minus 1. And on the bottom section on the table, you're going to go row minus 2. So as you can see, depending on where your element is located, you will take the row number, row minus 1 or row minus 2, and you'll do a brief calculation, and that is your first quantum number. So if your element is right here, it is in this A row, which is normally a 6, but because it's down here, we would subtract 2, and so the first quantum number for any element in this entire row is going to have a first quantum number of 4. We could come over here and look at this particular section, and we would know that the first quantum number for this group here is 5. And if we were in the center, let's say we're in this row, if we're in this row, the first quantum number would be the 4 minus 1, so the first quantum number would be 3. All right, so that brings us to the second quantum number. We'll find the second quantum number by looking at the, it's called the orbital quantum number, and it has an abbreviation of a cursive L. This one is dealing with the shape of the orbital. So the shape would be, for instance, if you look at my diagram down here, the shape would be that it is spinning in this orientation, or perhaps it's this orientation, or even further, it could be this one. Now, there are more than just the 3 shown in this particular picture, and they are abbreviated with the letters S, P, D, and F. Okay, it will help you immensely if you remember them in that order. So S, P, D, and F. And we are going to focus not on the letters this time. We'll need the letters eventually here soon. But for now, we're going to focus on the numbers that are assigned with it. So the S gets a 0, the P gets a 1, the D gets a 2, and the F gets a 3. These orbital shapes have assigned areas on the periodic table. And you can see in this brief graphic down here that the first 2 columns are assigned S, the last 6 columns are assigned P, the transitions are assigned D, and the bottom lanthanides and actinides are assigned F. All right, so back to our study guide. We're going to add the next layer. And so our second quantum number is called the orbital quantum number. And this one is the shape. And we are going to find that by sections. And this one's pretty easy to remember because the periodic table is already kind of broken up into these segments. So we are going to put an S, and we're going to put the number 0 there. Okay, so S is 0. Over here on the right, we're going to put a P, and that number is a 1. In the center, we're going to go D, and that number is a 2. And on the bottom, we're going to go F, and that number is a 3. So, to find the second quantum number, you will be looking again at the placement of the element and deciding what section it's in, and therefore what number it has. So if your second quantum number, your element is existing in this section here, it will have a second quantum number of 1. All of the elements in this entire section have the same second quantum number of 1. If we're down here on the bottom, the second quantum number is 3. If your element is here in the center in the transition sections, your second quantum number is 2. And if you're over here, your second quantum number is 0. So now you know row number, that was the first one, and then section. So you have 2 numbers for your quantum number series. Here's some practice. I've given you 10 elements across the periodic table. I would like you to find the first 2 quantum numbers for these 10 elements, and I would like you to do them in your notes. We will finish learning the rest of the quantum numbers in the next class. We'll have a second screencast that will lead us through the rest of it, and then we'll put it all together.